foolish to do so. At the same time, another minor hitch with that original Augusta consortium, well, not a hitch actually, it was an advantage. The Southwest universities privatized their computer center and said, you go off and be your own company, we're not paying you any more money. And SWERC became the software house Praxis. So fairly soon after Praxis started, 3 of us from STL moved to Praxis. And Praxis had a quality ethos which was sympathetic to rigorous and formal methods. And there we began to teach VDM and discrete maths once again. But unlike STL, which had, and ITT, which were very chary about letting any company secrets, as they regarded them, which included VDM courses, to anyone who might be a rival. Praxis were quite open about this, and the audience for the courses expanded to clients of Praxis and to the public in general, that is, all comers through the National Computer Center. Also, already Z was being used in Praxis with the fuzz tool, which was Mike Spivey's inspiration, Mike Spivey from the Oxford PRG, and that was notably used on KICS for IBM. So I was with Praxis for 7 years until 1991. Then I set up on my own, but I would just like to say something about Formal Methods Europe. VDM Europe started about 1985. I can't quite, I tried to find out the more precise date, but I think it was round about then. It started with European Commission sponsorship. And it had a champion within the European Commission, a chap called Karel de Vrendt. And I would like to mention his name because without his fostering this, it couldn't have come about. But after we'd been running for about 4 years, he said, he can't get us money anymore. We really do have to be self-sustaining to prove ourselves, as it were. And this was a bit alarming at first, but in fact, it has not just survived; it has thrived on, sustaining itself without any external funding. It became Formal Methods Europe rather than just VDM Europe, I think in 1993. It has regular symposia. They're all now well established, and it has many corporate members, and it's no longer just Europe, but worldwide membership and influence. So after 7 years with Praxis, I had secondments to the DTI, Information Technology Division, and also with Lloyd's Register. Now, I'm just going to leap forward a minute to, no. There was the kind of write-up of this talk will say a bit more about Lloyd's Register. At the moment, I haven't got slides related to it, so I'll just speak it. Lloyd's Register started off life as being Lloyd's Register of Shipping. It maintained a list of ships that were seaworthy. That's all it did to begin with. Just had a list. But then it started assessing whether those ships were seaworthy. And deciding that some were and some weren't, and then it started assessing the safety of all sorts of different engineering devices and systems. So it expanded its scope in that way. And so it was giving safety certificates to engineering systems, and then suddenly woke up to the fact that some of these engineering systems had software inside them, and they were blithely giving safety certificates to things with embedded computers and software, and they thought they perhaps ought to look at this a bit more closely. So they established a software research department of their own. At some point, a new field of work developed in Lloyd's Register, verification of safety critical software. And one of the first major contracts of this was static analysis using the MALPAS suite of the secondary protection system of the Sizewell B nuclear power station, which is something you would like to be safe. And another project was the safety assessment of a new digitized version of an electromechanical subsystem in the Hercules transport plane. So applications of formal methods in things that we would like to be working properly. Maurice Naftalin was involved in the Sizewell B using MALPAS. Yes, so that was Lloyd's Register. I worked as a consultant. I worked with them to sort of try and produce procedures for assessing software in kind of general terms. And I think we made some progress. I think my last serious project was Fortia, Formal Techniques Industrial Association. Again, this was established by Dinas Bjorna under the wing of FME, Formal Methods Europe, and the Colognet EC project, was some sponsorship with that. He wanted to set up an association of industrial, with a few academic organizations which were interested in formal methods and have a kind of club, basically. It was set up in 2003, culminating in a conference, a sort of initial conference in Pisa. Because I'd by this time worked in companies, I'd got small companies in particular, I got an understanding of what you need in a company to keep it working properly, and what are the legal pitfalls of that have to be avoided, and that sort of thing. So I knew what Dinas Bjorna was talking about with formal methods, and I also had this experience to draft the bylaws and charter of this organization to set it up. And I also helped him recruit the members of it. And there were 31 founding members from 15 countries, 5 of those countries outside Europe, including Russia and some other interesting countries which you might not expect would kind of come in to such a club. Well, it survived for a few years, but it didn't survive forever. But it was there for some time. Finally, well, not really finally, the last kind of substantial thing, I should talk about concurrency. Telecommunications involves a lot of real-time concurrent processing, and we were a bit nonplussed about what sort of formal methods, formal techniques we should try to use for concurrent systems in telecommunications. We experimented with CCS, but we also considered Petrinets and CSP and temporal logic. Yet it wasn't really clear how one compares them, what types of problem are they each suited, how they relate to each other. So to try and get some resolution of this, in 1983 we held a workshop And we invited a lot of academic proponents of different concurrency formalisms, those ones which I've listed and some others. And the way we structured this workshop was that we set 9 problems, and we invited these proponents of different formal methods at this workshop, and some in advance. We set the problems in advance to express the problem using their favorite formalism and to talk about it. And the result, we produced proceedings of it all, which was LNCS 207, the analysis of concurrent systems. And it's, I think it's quite interesting. There's the 9 problems, 1 or 2 of the problems no one touched. One of them was a very kind of down-to-earth problem of a cash point service, that is an ATM. We did revisit that under FME very, very much later. But there were problems like a two-way channel with disconnect, a simple network service, a kind of railway signaling, an array processor, parallel combinator reduction machine, and so on. It's all in here with the solutions. So I'm coming towards the end. Here's a sort of summary: 1950s to early 60s, formal grammars, grammar-driven parser generators. It enables compilers which are better related to the languages they accepted. And in the 60s to 70s, we began to see semantics appear, semantics of languages, to start with based on lambda calculus, but then denotational semantics, operational semantics, and producing, inspiring Dijkstra's pre- and post-conditions, and enabling proofs of the correctness of programs. And so this kind of led into methods, formal methods, in the kind of very late 1970s and into the 80s. You could express a functional specification as the semantics, essentially, of the desired end product. So you write the semantics of what you want to be written before you've written the program that is going to have those semantics. And that's really what a formal functional specification is. The methods are based on semantics because of that kind of connection, because of the connection from semantics to functional specifications. And then in the 1990s, we did see some more aspects of the life cycle expressible in formal terms, in particular requirements. And the Forest Project was a particular example of that. I've sort of come up to the 1990s. What about the last 10 years or so? And this is just kind of thoughts of mine. A programming language is the medium through which we communicate with a computer and tell it to do what we want it to do, to instruct it to do a desired task. And we're used to the idea of this medium, the programming language, being a linear script of symbols. It's a linear text. But more and more, we're instructing computers to do things in a way which is not expressible as a linear script of symbols. If you just take something as mundane as a spreadsheet is an array of expressions. And you compose these expressions in a haphazard way through a kind of conversation that you have with the package. And in the end, when you're satisfied with it, there you have this array of expressions. But it's not a linear language that you're using to produce that. And the composition of a web page is even more non-linear, if you will. It's achieved through a communication, sometimes using movement of a mouse and so on. Now, all that it mitigates against having a record of the construction process, which is very awkward to apply quality procedures, let alone a formal description. And so in our concentration of program language semantics being the semantics of a linear script, I'm asking the question, are we once again looking under the wrong lamppost? So I would like to acknowledge those people, Carol de Brent I've already mentioned, and all the others. The presenters at the 1979 Copenhagen Winter School, there's a long list of noble people who kind of gave some of us attending it a kind of shock of the new, and numerous other colleagues that I've worked with. I'm working up some notes for this talk, and most of them will be mentioned. And finally, if you have any questions, I hope they won't be too searching. Here are some references you can gaze at while I attempt to answer any you have. Thank you for your tolerance.
Thank you very much, Tim. Whirlwind tour around the last half century. He only wants to do 40 years, but he wants to do 50 years, half century. Does anyone have any questions for Tim or Brian?
Yes.
Just your final thing about the way that we now do things, leading to a different angle on things. I think that's bang on, but it's interesting that some of the techniques that are coming up in order to deal with that abstraction and complexity, like, for example, the project I was on recently, which was designing a generic data acquisition processor for data center research, is what it was about in the medical area. But the way it was being done was with a kind of a swarm of post-it notes all over the place, sort of categorizations and people walking around it. So there was an emergent ontology which was sort of combed out by it being visible to the whole team. But what was perhaps more interesting in terms of what you're talking about here is we were sort of relating that to the user experience design. And one of the key techniques for keeping that in order was preconditions and postconditions. So not expressed vigorously sort of formally, but also with that kind of short cycle agile development, which sort of goes into
Yes.
sort of methodology. We're actually testing, the idea that you're testing by execution in an iterative sort of way. So I think there may be something emerging out of that that would enable some of these old ways to actually roll back again into the way that this massive complexity that we've now got behind the appearances that we use to manage things are actually rolling through.
Good. Well, I'm glad to hear it, but I guess we'll see what happens.
It's a very short answer.
Well, I didn't. It seemed to be a question exactly, but yes, good.
Any more comments or questions? Well, I've got one question I've always been asking, because because you mentioned software engineering starting in 1968 with NATO, but where did formal methods actually start? I've seen one book on mathematical logic that had the term formal methods in it before we did.
Oh, I see. When did the term? When did the term?
When did you first hear it?
I think it was about 1980. It's the first time I remember it, the actual phrase being used.
Yes.
But I mean, some other people that I didn't know at the time might have been using it much earlier.
I think so. It was sometime in the 70s.
Yeah.
Exactly when. So who did you hear it from?
Well, I mean, there was when we had this consultation with Cliff Jones, I think one or other of us, it might have been Mel Jackson, suddenly started calling this a formal method, and the phrase sort of got adopted. I mean, if you recall, Cliff Jones's book was called Software Development: A Rigorous Approach, and he was calling it rigorous. Yes. I first heard that term reification at an Algol 68 conference. It was a sort of 10-year celebration of Algol 68. I don't think it was used much more than 10 years, but someone at that conference used the word reification, and he explained it for those of the audience who didn't have a classical background. He said it means making something into a thing, and I always rather liked that. So yes, much better than concretize or something like that. Horrible.
So ask Mel Jackson.
Well, except that he seems to have vanished. I've tried to Googling him, but I just get the names of strange female pop singers instead of him.
Well, you never know.
No, I'm not quite sure where he is these days.
Yes, Michael Jackson.
That's a different one.
Yes.
The phrase formal method is rather hard to interpret in some ways, because it invites the question, a method for what? Can you suggest an answer to that question?
Oh, well.
I mean, the method is a way they're doing something.
Yes.
Is there a general answer to the question, what are formal methods for, or are they all for different things?
I think, well, in our context, I think they're for a few different things, but perhaps different activities which are parts of a bigger whole. So, I mean, the kind of normal, natural one, in a sense, is actually developing software from specification to an implementation. But then you might think, well, you could use the phrase for developing a language definition and that sort of thing, which is why I kind of perhaps applied it to formal syntax and so on in the late 50s and early 60s. And also, of course, later on it's been applied to requirements capture, and people have talked about testing and so on. So doing testing in a formal way, rather than just trying to sort of dream up tests that you think might exercise what you produced. Yes, it is a bit vague, I suppose, but kind of generally focusing in a rather blurred way over the total activity of producing software from what do we need to do down to the final delivery.
There was VDO came into VDM.
Yes.
But then Z was always a formal notation. We always had it.
Yes.
It's not a formal method.
Yes.
There's an interesting difference between VDO and there. I remember that was always a big discussion in the early days of Z.
Yes.
Any more comments?
No, there's that funny paper, isn't it? Comparing Z.
Which funny
VDM. I can't remember it now, but we had it in our journal, in our newsletter.
Okay.
Comparing VDM and Z. It's
Right,
a dialogue between.
Oh yes, okay, that was John Nichols, wasn't it? Yes, okay.
Okay.
Any other comments?
No.
Next 50 years. Will Brexit affect formal methods?
Okay.
Otherwise,
Right.
we'll say thank you very much to Tim. Before you rush off, a few announcements. We always have dinner with the speaker if anyone would like to join us for dinner, there are a few extra places, so come and see me. It's normally about £30 or so for the crusty pipe, which is in Covent Garden. It's only about 5 minutes walk away. So do come and see me if you'd like to join too. Future meetings, well, I guess I'll just advertise I'm giving a talk, and yes, another talk on Alan Turing, because of course I'm just here to sell my book. If anyone wants the leaflet, you can get 20% off, so you can pick up a leaflet if you like one. But I'm giving a talk on Alan Turing at London South Bank on Monday, so if anyone wants to come to that, I can give you details. But our next real FACS talk is on 4th of May, which is actually going to be a joint FME and FACS talk. FME are going to have their AGM before that at 3:30, but you don't have to go to the AGM, that's a separate event, although you're welcome if you'd like to. And the talk will be in the evening by Dr. Rainer Arnold from Technical University of Darmstadt. So we're getting a European speaker. FME will pay for his flight and will pay for his local expenses. So I hope to see some of you there. You can book online. I think it's all online at the moment. We're just organising a June meeting with Colin Snooper from Southampton. That should be on the 15th of June. It's not online yet. But if you want to make a note of that date, you're all welcome to that too. So thank you again, Tim. Thank you.